Greetings, welcome to exercise 5.50, child care hours. The China Health and Nutrition Survey aims to examine the effects of the health, nutrition, and family planning policies and programs implemented by national and local governments. For example, collects information on the number of hours Chinese parents spend taking care of their children under age 6. The side-by-side box plots below show the distribution of this variable by education attainment of the parent. Also provided below is the ANOVA output for comparing average hours across educational attainment categories. So the educational attainment is the factor or the variable that we're looking at. We have a one-way ANOVA here, so we have one variable with several levels. So we have primary school, we have lower middle school, we have upper middle school, we have technical or vocational, and we have college. And then we have the corresponding ANOVA table. They didn't give us any more information other than the side-by-side comparative box plots to use to help us determine whether or not we can use ANOVA to analyze this data. But that said, we will do it. We will go forth and do the task that has been assigned to us. Okay, so what do we need to do? Well, we need to, first of all, of course, with any good ANOVA test, we need to come in and write the hypotheses. So let's do that. Okay, so our null hypothesis is going to be what? That mu1 is equal to mu2 is equal to mu3 is equal to mu4 is equal to mu5. Because why? Well, there are 5 levels to our variable here, right? Okay, so what does the alternate say? Alternate says that what? At least one differs. And again, we need to, should be an A there, we need to check our assumption. So how do we check our assumptions? Well, first one is independence. I think we probably can assume, since this was a study done, excuse me here, this study was done how? It was collecting information on a number of hours of Chinese parents. It's observational. We can go ahead and just roll with independence here. We'll just say, okay, check. All right. 2, what else should we look at? We got to check normality. What about the normal condition here? Okay, so the normal condition, well, we know that this was a fairly large study, and we can tell that by taking a look at education and residuals. So we know that it was basically, 798, almost 800 people. So broken up across the 5 categories. Probably, if we're assuming that those are roughly spread out equally among those, which is probably not a super safe assumption, but we'll roll with it, because probably the college group is maybe a little bit smaller. We'll just assume that the sample is large enough for normality in each one of them. Okay, we're not given a lot of information, so we'll have to roll to what we got. Okay. And the third one is that the variances are the same across each of them. And again, I'm just going to have to check that because we really don't have, well, I take that back. We do have a little bit of a tool to check the variances between them. And the variances between them we can check based upon what? That all of the interquartile ranges appear to be roughly about the same size. So we can go ahead and hopefully assume that the variances are approximately equal to each other. Obviously, they're not the same, but these boxes aren't a huge width different from each other. Notice that in every one of the cases of the box plots that we have outliers in here, and that it appears that pretty much without exception that all of these are skewed a bit to the right. Okay, so back here with the normality condition, the reason we can again run with normality is because we've got a rather large sample size. Okay, now that we've checked our assumptions, we can come in and we can do something about finding the conclusion of the hypothesis test. Okay, and really, as I stated in earlier problems, we only really need those 2 numbers to help us out here. We need our F value and we need our P value. And really, to tell you the truth, the only number you really need is that number, your P value. So to conduct the hypothesis test, again, it's always good to think about it in terms of the distribution you're working in. You've got an F distribution here. The F statistic is 1.26. So 1.26 probably be about yonder. And the corresponding shaded region that goes with that is going to be your p-value. And the p-value in this case is 0.2846. which we see is greatly bigger than 0.05 or 5%. So therefore, again, we would end up failing to reject the null. All right, now what's your part you need to do for me is you need to put that in context. What does fail to reject mean in context of this problem? Don't just write down fail to reject as to what your answer for it is. Make sure you know what that means. Okay, thanks. Hopefully that helps you. If you have any questions, don't be shy about posting to the Q&A forum.